All right, here we are back at it with related rates. So let's look at this next one. Okay, so given that dx dt equals -6, y equals 4, and x times y equals 12, find dy dt. So you might be looking at this and be like, I have no idea what to do right here, right? What are we even differentiating? Well, we know that dx, we have a dx dt, right? And we couldn't just differentiate this like y equals 4, because if we differentiated y, it would just be dy dt. So this is like a value that we're going to plug in later, and that's how we know that. But this does look like this is like a function that we're going to be evaluating. And again, we're not usually going to have like really abstract things like this. It's going to be something like really applies, possibly to like physics or something. I'm sorry to those of you who hate physics. You know who you are. Uh, no, it's just going to be a more applicable thing, but this is, again, just kind of an abstract example to get the process down. Okay, so we're going to differentiate this function right here, x times y equals 12, with respect to t, right? Because x is no longer our independent variable in this, t is. So we want to find the derivative of x times y equals 12 with respect to t, right? So we want the derivative. Let me try that again. The derivative with respect to t of x times y equals 12. Okay, so you recognize right away that this is the product rule, right? So we need to find our the derivatives of each of our things. So we can define this as, there's like this spot on my tablet that just doesn't want to write. Wonder if it has to do with the fact that my children use my tablet. So what happens? Can't have anything nice. Okay, so f of x is going to be x and g of x is going to be y. So that makes f prime of x. Well, the derivative of x is just 1. But remember, this is a implicit differentiation thing because we're differentiating with respect to time. In fact, we should probably say f of t and g of t, right? Because these are actually functions of time. Okay, so the derivative of x with respect to t is dx. I just have to find the right spot to write dt. Okay, dx dt is the derivative of x with respect to time. Okay, and then the derivative of y with respect to time is dy dt. Okay, so then we use our product rule and we go fig plus gif. So the derivative of x times y would be dx dt times y plus dy dt times x. And we differentiate this side as well, right? So we have the derivative with respect to time of 12, which is just 0. Okay, and so then we want to find dy dt, right? We want dy dt. So let's just plug in what we know and see if we can figure that out, okay? Because we have 4 variables right here, right? This is a variable, it's something we don't know. This is something we don't know. This is something we don't know. And this is something we don't know. So we were given some of this stuff though, right? So we were given that, let me see, dx dt equals -6 at this point. Okay, so we can plug that in. So dx dt is -6. We were also given that y equals 4. Okay, and we don't know dy dt. That's what we're trying to find. Oh man, this is what happens when you try to do technology. Okay, let's see if it does it. D, Y, D, T. That really, it just does not want to show up there for some reason. It's like my touchscreen is a little off on this. Okay, so dy dt. Oh man, this is going to be terrible. I am sorry, guys. We don't know. dy, let me see if I can find a spot that it'll, if I can write it somewhere. dy dt. Okay. And then x, we also don't know. So what are we going to do about that, right? So we have here negative 24 plus dy dt x equals 0, but we still now have two unknown variables, right? Okay, so what are we going to do about that? Well, we can remember that that one step where it says like write some variables in what does it say? I should just read it right here. Look for secondary relationships and to reduce the number of variables. Okay, so we're going to do that. So we know that we can relate x to y, right? In fact, we know that x times y equals 12. And we know in this instance, y equals 4, so we have 4x equals 12. So what does x have to equal in this specific spot? Well, x has to equal 3. Okay, so then we can bring that 3 over here and plug it in for this x. So now we have negative 24 plus 3 dy dt equals 0. And so then we can just solve for dy dt because that's what we want to know, right? So we have 3 dy dt equals 24, and therefore dy dt equals 8. So the rate of change of y with respect to t at these specific places where y equals 4, x equals 3, and so on and so forth is 8. Okay, let's take a look. Let me see. Should we do the next one on this video or maybe one more video? Yeah, I think we'll do the next two on another video.